Yo, 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 yo. All right, guys. Linear, exponential, and quadratic models. So basically what we're doing is we're going to look at different models or different tables, really, just compare them and determine if it's linear, exponential, or quadratic. Now, we've talked about linear functions in the past. A linear function is a function that if I graph it, it makes a straight line. That would be linear. Exponential have this shape right here. And then the quadratics, what we're working with, where they have the U shape. Now, these differences over here, where we're talking about ratios or second difference or first difference, get those definitions down and we'll talk about what they mean when we start getting into it. So really what we're going to mostly be doing is just looking at tables and determining if it's a linear function, exponential function, or a quadratic function. Now, the way we do that is we find the differences in y's for consecutive x's. We're finding basically the rate of change. Okay, so when I look up here, my x's are counting by ones, so we're going up one each time. So that's good. That makes this really easy. So then I want to figure out, well, what are my y's going up by? Well, this one's going up by 2 each time. That's supposed to be an arrow, not to confuse you. So it's going up by 2. So because the common difference here, because this is the difference. So if this 2 would be the difference between the second and the first. It's going up 2 each time, so that's my common difference. So the first difference here, or the common difference from y is constant. It's just going up by 2 every single time. So this would be linear. So whenever we look for the difference and it's just constant right away, it's the same. Like we're 2 over 1, 2 over 1, 2 over 1. That's a constant rate of change. So therefore, this is a linear function where the difference is just constant. Now, this would be an example of our x's are going up by 1. But now, if we look, my y values are not going up by the same amount each time. This one's going up 6, up 10. This one's going up 14. And this one's going up 18, it looks like. And I can figure out by finding the difference. We call them differences because the way I would figure out this 18 is I would actually do 51 minus 33. The difference between 51 and 33 is 18. So not linear because this is not constant. It's not the same. It's changing, right? It's going up a little bit more each time. This is when we learn by finding the second difference in y. So let's pretend like this is a first difference table, right? So we had y, then here's my first difference. Well, now what I can do is I can find the second difference. Well, the second difference is I'm finding the difference between these two. So from here to here, it went up 4. From here to here, it also went up 4. And from here to here, it also goes up 4. So when the second difference is constant, like so, that makes it a quadratic function. So quadratic functions is when the first difference is not constant, but if we notice that pattern, it was increased by 4 each time, so that second difference was up 4. So this is a quadratic function. And that's it. That's all we're trying to do today. Just determine the difference between linear, quadratic, and exponential. Now, for this one, if I was looking at the differences, let's see, we go up 1, up 2, up 4, up 8. Well, the problem with this one is now the first difference is not constant, but if I found the second difference, this is up 1, up 2, up 4. It's not constant either. So the first and second are not constant. So now that means it can't be linear, it can't be quadratic. It could be exponential. The way we find out if it's exponential, and hopefully this is review, hopefully we remember this, is we look for the constant ratio. So we look at consecutive y's, we find the ratios. So I want to figure out what's the ratio of this y over this y. So these differences no longer matter. And this is going to be 16 over 8, which is 2. If I compare these consecutive y's, that's 8 over 4, which is also 2. 4 over 2 is 2, and then 2 over 1 is 2. So by finding the ratio of consecutive y's, right next to each other. I got 2 each time, so therefore it is an exponential function with a constant ratio of 2. That's a p. There you go. Okay, try these 2 on your own. Tell me if it's linear, quadratic, or exponential, please. Okay, so this one's going down 3, down 9, down 15, down 21, so it's not linear. Well, it looks like the second difference is going down 6 more each time, so therefore this A is quadratic. Sorry, I'm using my mouse, so that's why my writing, not that my handwriting is ever that much better, but it's a little bit more difficult with the mouse. This one we're going up 8. So this one's going up 24. Oh man, 108 minus 36. It's a large number. I can tell you right now it's not going to be quadratic or linear. Mainly because the second difference is definitely not the same, right? So I can stop right there. So now I know it's not quadratic, I know it's not linear, so I can check to see, is this going to be exponential? So I can find the ratios of the next y divided by the one before it. 12 over 4 equals 3. 36 over 12 is 3. 108 over 36 is 3, and then 324 over 108 is 3, so this one is exponential. Okay, that's it. Nothing else for you guys. And for things to remember, draw a happy face though that has mad eyebrows. See, it's confusing. Okay, do these 2 independent practice problems, and that's all I got for you guys. Thanks for watching. Good day, out.